All right. Hello, ladies and gentlemen. Today we're going to be talking about how to solve logarithmic equations. So there's about 6 of them. We're going to do 6 or 7 of the types we're going to talk about. So again, we're going to break this up into thinking about 3 per video. So you'll have 3 3 types per video and a couple examples on each type. All right. So the first one we're going to start off with is log equals hashtag or number sign. Basically means log equals some number. So you'll see some type of logarithm expression and it's going to equal a number. To solve it, we have to rewrite the log equation as an exponent. So let's do example number 1. Example number 1, we have log base 2 4x equals 6. So you see we have a log base 2 4x expression on the left and a number on the right. So again, using our loop technique that we discussed in class or you've seen in a previous video, we're going to start with our base, our little subscript here. We're going to make our little loop, come around, and wind back up at our answer here. So it's going to go 2 to the 6th power equals 4x. All right, so from there, we just simplify the left side. 2 to the 6th power is 64, and it's going to equal 4x, and we divide both sides by 4, and get 16 equals x. All right, so it's pretty straightforward. If it's log equals a number, or log equals hashtag, basically meaning some number. Back in the day, the pound, we call this the pound sign on cell phones or phones, and it usually meant a number, okay? So next example we're going to do example number 2, which is going to be log base 3 x minus 1 in parentheses equals 2. So again, let me make that 3 a little bit better. Sorry, guys. Ladies and gentlemen, sometimes I get a little ahead of myself. All right, so now we're going to do our loop technique again, starting with our base. Come around, make our little loop. And make it 3 to the 2nd equals x minus 1 in parentheses. All right, so we're going to go ahead and simplify. So 3 to the 2nd power is 9, and it's going to equal x minus 1. All right, we can go ahead and drop the parentheses since we don't have to worry about doing anything else with that. So now, just like a regular one-step equation, we're just going to solve it by doing the inverse, adding 1 to both sides, and get 9 plus 1 is 10 equals x. All right? So that's pretty much it for that type of problem. Now, the last kind of problem we got to deal with, if you notice, in the first problem we had a monomial as our on the right side, and on the second one we had a binomial. Well, there's a reason why we had the parentheses. The parentheses was to say that this expression or this polynomial goes with this particular log. What if we have something like example number 3, where we have log base 5 x plus 1 plus 8 equals 10. You see how the plus 8 is not inside the parentheses? That means it's not a part of this logarithmic expression. So we have to get rid of it or move it by doing the inverse operation, which in this case is subtracting 8 from both sides. And we're going to wind up with log base 5 x plus 1 equals 2. So the reason why we had to do the first step was because, remember, we have to have log equals a number. It's not log plus a number equals a number. So we can't have that. It has to be log equals a number before we can do our loop technique. So now that we have log base 5 x plus 1 equals 2, we do our loop technique, come around, and we write it as 5 to the 2nd equals x plus 1. All right, 5 to the 2nd, we can go and simplify and make it 25 equals x plus 1. We're going to subtract 1 from both sides and get 24 equals x. All right? So that's pretty straightforward, guys. It's the simplest one that we're going to do, and it's actually the base one we're going to do because we're going to use all the other problems we're going to do in a few minutes and so on. We'll always follow the same rule for this particular type of problem. All right? So that was if we had log equals hashtag or log equals a number. All right? Next one we're going to deal with is log plus log equals hashtag. All right? So again, the first thing we want to do is When we have log plus log, we have to condense it. So that's going to be our first thing. So we're going to condense left side and then rewrite as exponent, doing our loop technique. All right, so let's do example number 1. Example number 1, we have log base 2x plus log base 2 3 equals 7. Let me that to be a little bit better so it's, say, Mr. Harper, what is that number? Still not better. Sorry. All right, there we go. All right, so again, we're going to condense. So using our condensing rules, remember if we're adding, we're always going to, and since we're doing log plus log, we're going to be multiplying. So this now condenses to log base 2. And I'm going to put the 3 in front just because I like my number in front and then my letter in the back. So 3 times x equals 7. All right? So then now that we have the same expression like we did in the first one, that's why I said that we were going to do a base problem, and that would actually be the grounds for how we would write the other ones. All right? So then we're going to do our loop technique again, and we read it as 2 to the 7th equals 3x. Well, 2 to the 7th power is 128 and 3x. So again, to solve for x, we're going to do the inverse. But instead of multiplying, we're going to divide. And for these problems, guys, you always want to leave them, for our purposes, leave them as fractions. You don't have to do as a decimal. Maybe a math class, a teacher might require you to write as a decimal. For our purposes, we're just going to leave it as a decimal. But we do want to make sure it's in lowest term. I mean fraction. But we're going to make sure it's in lowest terms, which in this case is going to be 128 over 3 equals 3 equals x. All right. So leave it as a fraction, guys. On the test and the answers are as fractions as opposed to decimals. All right. So let's do example number 2. Example number 2, we have log base 5, x plus 4 in parentheses plus log base 5, x minus 4 in parentheses, and that's going to equal 2. So again, guys, when we're adding, remember we multiply when we condense. So this becomes log base 5, x plus 4 times x minus 4 equals 2. All right? So what I like to do, now this is where you have a little leeway here, guys. If you want to go ahead and do double distributing or the box method to multiply these two binomials, that's fine. I typically wait until I do my loop technique and then I do that. So that's what I'm going to do. I'm going to do my loop technique first, and then I'm going to come back and go from there. All right, so we're going to do a loop technique and make it 5 to the 2nd equals x plus 4 times x minus 4. All right, well, 5 to the 2nd becomes 25. And then if we do our double distributing, you notice that first of all we have the same letter, we have the same number, we have a plus sign and minus sign. So this means it's the difference of squares. So all we're going to do is multiply the first two numbers and the last two numbers, because what's going to happen is the other numbers are going to cancel out. Because remember, this is going to become x squared minus 16. Because x times x is x squared. Positive 4 times negative 4 is negative 16. Okay? So then now, because I only have one x here, guys, I'm going to solve for x. So I'm going to add 16 to both sides to isolate our x. It gives me 41 equals x squared. And then from there, we're going to do our square root. And then wind up with the square root of 41 equals x. Now, technically, we should say plus or minus because, again, that is the correct way to say plus or minus. Square root of 41 is equal to x. All right, so that's it for example number 2. Example number 3, we got a little wrinkle we got to do here. It's not really a wrinkle, but it's just an extra step that we didn't do before. All right, so we have 2 times log 2x plus log 25 equals 3. All right, so first thing you want to do is, because you have a 2 in front of your log, remember that's going to be our power rule, so that means that we're going to take this coefficient and we're going to move it to the back as an exponent of the logs attached to it, the logs in front of. So since 2 is in front of log 2x, we're going to put the 2 as an exponent here, and we write it as log 2x, we'll put that in parentheses, and we're going to square it, plus log 25 equals 3. All right, so now we condense like we did before. Since we're adding, we're going to multiply, so it's going to become log 2x squared times 25 equals 3. All right, so remember when there's no base, remember that our rule states that when we don't have a base, the automatic or invisible base we're going to use is 10. So we'll write 10 here. Then we're going to do our loop technique and write it as 10 to the third equals 2x in parentheses squared times 25. All right, so we got a couple things we got to do. We got to go ahead and simplify the left side, which 10 to the third is actually going to become 1,000. And then over here, when we distribute this 2 as an exponent inside 2x, we wind up with 4x squared, and that's going to be times 25. All right, so then the next step we want to do is we want to multiply 4 and 25 and get 100 equals 100x squared. So again, because we only have 1x squared, we're going to divide both sides by 100 and get 1,000 divided by 100 is 10 equals x squared. And just like in the last example, we're going to find the square root, and we're going to wind up with plus or minus the square root of 10 equals x. All right? I think we've got enough room for example 4 without going to another page. All right, so example 4, we got log x plus log x minus 15 equals 2. All right, so again, we don't have any coefficients in front, so we don't do our power rule, but we do need to go ahead and condense and add. So we're going to make it log and multiply, log x times x minus 15 equals 2. All right, so remember, no base, so we're going to use 10 as our base because that's our invisible base. So we're going to say log, so we're going to say 10 to the second equals x times x minus 15. All right. I think I'm going to run out of room here, but anyway, that's a good thing about this. You can continue on the next page. All right, so 10 squared is 100. So we're going to distribute the x on the right side and get x squared plus minus 15. Sorry, saying plus 15. I forgot there was a minus sign. So it's minus 15x. Now this time, because I have two x's, I can't isolate it, so I'm going to have to bring the 100 over and make it a trinomial, and then factor it. So it should become 0 equals x squared minus 15x, minus 100. All right? So let's go on to the second page, and we'll do that, and then this will be the last example for this video. And then we're going to get x squared, so we rewrite the x squared minus 15x minus 100 equals 0. All right? So here we're going to do our factoring. So remember, we're going to do our x method. We're going to write negative 100 on the top and negative 15 on the bottom, because we always take our last number, put it on the top. Our middle number goes on the bottom. Then we come over here and list our factors of 100, which are 1 and 100, 2 and 50. Let me kind of come over a little bit more. I realize I'm a little further over than I want to be. Sorry. So come over here. 100, 1 times 10, 2 times, 1 times 10, 1 times 100, sorry. 2 times 50. 4 times 25, because 3 does not give us it gives us a decimal when we divide 100. So remember, we don't want that one. 5 times 20. 6 gives us a decimal, so we can't use 6 as a factor. 7 gives us a decimal. We don't want that as a factor. 8 also gives us a decimal. We don't want a factor. 9 gives us a decimal. So the only other factors we have are 10 and 10. All right? So then we come over here and we apply our rules. Since the first sign is negative, the second sign is negative, that means that the biggest number is going to get a minus sign. So I'm going to put a minus sign by all my big numbers, like 100 is big, 50 is bigger than the other factor. 20 is bigger than the other factor. And then 10 and 10, just put it anywhere. Then we're going to put a plus sign here for all my other ones. All right, so 1 minus 100 is negative 99. 2 minus 50 is negative 48. 4 minus 25 is negative 21. 5 minus 20 is negative 15. So we can stop there because we want 5 and negative 20 as our factors. All right, so we're going to come over here. We're going to say x plus 5 times x minus 20 equals 0. And then we just need to set both of these binomials equal to 0 and solve for x. So we're going to subtract 5 from both sides on the left for the first one and get x equals negative 5 for the first one. Over here, we're going to add 20 to both sides and get x equals 20. And that will be our solutions for these problems. All right. So in the next video, we're going to talk about the last kind of log. It just got a little long, so that's why I didn't want to do that one on this one. But anyway, stay tuned for the next one. Thank you for listening, and I will see you I will be talking to you in the next video. Bye.